Is there an optimal angle for throwing something far? Assuming the same force of course, and just counting till the first bounce. I feel like a minimal angle will mean the object will bounce quick soon as loses some energy, and obviously an angle close to 90 degrees won't work either. Is it a clean answer like 45 degrees? Thank you in advance. I have no idea why this is bugging me. Ignoring air resistance 45 degrees is optimal. With air resistance it'll be a touch lower I'd expect. All depends on the aerodynamics of the object, setting this occurs in an physical ability of the thrower. For example, something like a perfect sphere being projected at a constant speed in a vacuum would peak at 45 degrees, but a situation like an old lady throwing a frisbee in a drafty environment might benefit from a lower angle, maybe between 30 to 45. It is 45 degrees indeed, but only if you ignore air resistance. When deriving the formula and throwing some trigonometric identities on it, you end up with a term for the maximum distance. Xmax equals v(g) times sin, 2 times theta, with theta being the angle you throw the object in relation to the ground. This sign has its maximum when the argument has 90 degrees. Since the argument is 2 times theta, it has its maximum when theta equals 45 degree. When you include air resistance, you want to choose an angle below 45 degrees, typically between 30 to 40 degrees. That depends on the circumstances. With a lower angle you have less airtime, which will decrease your effects from the air on the ball. Excluding air resistance, for example, would give you the same distance for 30 degrees and 60 degrees, but the 30 degrees throw has a much lower airtime, and therefore has a longer distance due to lower resistance effects in reality. Throwing is different from launching a projectile, because the mechanics of the muscles comes into play. Your muscles may not work as efficiently at an optimal 45-degree launch angle. For instance, the optimal angle for shot put may be about 37 degrees. The difference from 45 degrees does not have to do with air resistance. It's the muscles themselves that are being analyzed. Also, the fact that the launch point is higher than the landing point means even the theoretical optimum is more like 42 degrees. Articles I found on Javelin suggest the optimal angle is 30 to 36 degrees, though I didn't locate the same kind of theoretical analysis. This seems to come from people studying video of the throws. I also googled for baseball throws. There the consensus seems to be that air resistance is significant, and that the optimum may be about 40 degrees. The parabola at landing would best be at 45 degrees. The angle you start at would be dependent on the object's air resistance and mass. The longer and flatter of the object's trajectory, the further it will go, as it slows due to air resistance. The best angle to land at would be 45 degrees.
Don't forget to like and subscribe so you don't miss our next exciting video.